Hello students, today we are going to learn how to do another experiment, light emitting diode characteristics. This light emitting diode is nothing but LED, or in short we call, and it works on the principle of electroluminescence. And this electroluminescence is nothing but it's a phenomena of a material emitting light when electric current or an electric field is passed through it. Okay, so we'll see what is the aim of this experiment. The aim of the experiment is to study the VI characteristics of the light emitting diode. So nothing but how the current varies through the LED when voltage is supplied to that. Okay, how it will vary, how current varies with respect to voltage. That is what we are going to study in this particular experiment. The apparatus required for this experiment are, it's a LED characteristic board. Nothing, this is the board which we are going to use, and power supply. We need to have digital voltmeter. This is the power supply. This is the digital voltmeter. This is the ammeter which we have. These are the resistors which we are going to use. These are the LEDs which we have. Okay, so using this, and also we have got some connecting wires. So we are going to use these connecting wires to give the connections to these different apparatus which we have got. The formula behind this is EG is nothing but which is equals to EC minus EV, which is equals to H nu, where EG is equals to H nu by Hc by lambda. That is what you can write as such, where nu is nothing but the frequency, lambda is the wavelength, and EC is nothing but the energy of the conduction band, and EV is nothing but energy of the valence band. So these are the terms which are involved in this. So it's not that actually required, but just to have a knowledge, we are just trying to know about this. EG is nothing but, we can write simply EG is equals to H nu, or EG is equals to Hc by lambda. Coming to the circuit diagram, this is what the circuit diagram which we have got. We have to follow this circuit diagram to study the VI characteristics, and we are going to get a model graph like this for voltage on x-axis and current on y-axis. When we draw, we get a graph in such manner. So we are going to study the VI characteristics by constructing this circuit. On this circuit board, or in this board, we will give the connections, then we will vary the voltage and note down what is the corresponding current values which you are going to get. Then we will be drawing a graph, and we will be studying how much is the threshold voltage as well. We can be able to know that. Now let us start connecting the circuit diagram. We will give connections. So as I already mentioned, the circuit diagram goes in this way. So we can see that we have to follow one particular order. Okay, we have to follow one particular order. Either we go from positive of the supply and we go to the resistor, and resistor is going to be connected to the ammeter, and then it is the LED. This is the symbol for LED. These two arrow marks, whenever it has been given, then this diode is going to be called as LED. This is the representation of LED. Okay, so we can have differences. Okay, we can make out the difference between normal diode and LED as, if we don't have these arrows, then it is called as normal diode. But when you have these arrows which are pointing outwards, then this symbol represents the LED. Okay, now after that, this LED has been connected to the power supply another end. This is how we will have the circuit connections done. After that, we will connect this voltmeter parallelly to the power supply. So that is how we have to give the connection. So let us start with one end. We'll start with the power supply itself. Positive end of the power supply goes to the resistor one end. Resistor another end goes to ammeter positive. Ammeter negative goes to diode positive, and diode negative goes to the, and this where it goes? It goes to negative of the power supply. Once we have done this outer circuit, this outer part, when we have done, then the loop is said to be closed. Then we will connect 1 voltmeter parallelly to the power supply. So let's start connecting the circuit diagram. So as I told you, we'll start with the positive end of the power supply itself. So here is the positive end of the power supply, that is going to go to one end of the resistor. We do have different resistors here. It is 100 ohms, 220 ohms, and 350 ohms, and 470, 560, and 1K also. We will choose only one particular resistor. Let me take one resistor as 220 ohms. Then the other end of the resistor has gone to the positive of the milliammeter. We are going to connect the positive end of the milliammeter. Then the milliammeter negative end goes to where it goes is it is going to go for diode positive. See, we do have different diodes which we can see here. Okay, we can choose these two are one color, this is one color, this is another color, and this is another color. We'll choose one color at a time and then we'll tabulate and we'll find out the characteristics of each and every color here. We do have yellow color, white, blue, we can say. This is green and red. That is how we can have. Now presently I'll just go with blue itself. So one end of the diode, see, this is already given positive and negative end. Okay, so I'm directly connecting to that, and the negative end of the diode goes to volt power supply negative. Then the outer part is connected, the external circuit, outer circuit is been done, the inner one is left, that is nothing but voltmeter. We will be connecting that exactly parallel to the power supply. So now the voltmeter, this is the positive and this is the negative. Now this positive and negative are going to be connected to the positive and negative of the power supply itself. See, this is the positive, I am connecting to it to the positive end of the power supply, and negative end is connected to negative end of the power supply. So this is how we connect parallelly to the power supply. Now we switch on the kit and we'll reduce. See, we can see the power supply is it can vary from 0 to 15 volts. We will start with 0 volts itself. Okay, we'll reduce the reading. Now we need to tabulate the variations in this tabular column. So in this tabular column, we need to take first column serial number, voltage and current as such. Okay, we will be filling up these values. Okay, so initially for this particular LED we are doing now. So for this LED we will vary the voltage and then we'll note down the current value. Slowly we'll rotate, okay, with a variation of 0.5 or 2.25 also you can take. So I'll go with 0.5. So for 0.5, how much? For 0 volts, how much is the current? You have to note down. For 0 volts it was 0 only, so I'll just simply write down for 0 volts. So for 0 volts, this is the first one. For 0 volts, it is the current is 0 milliamperes. Then we'll vary for next 0.5. Yes, for 0.5 it's still 0 itself. For 0.5 it is still 0. Next for 1 volt. Yes, it is for 1 volt. It is still for 1 volt. It is still 0 milliamperes. Then we will see 1.5. Slowly I am rotating this knob. Oh, it's 1.5. So we have to get to 1.5 volts. It's still 0. So for 1.5 also it is still 0. Then slowly I'll turn this knob, rotate this knob. I'll have to put for next for 1 volt. So I'm rotating this knob for 1 volt. Oh, sorry, 2. Okay, for 2 volts also it is 0. For 2.5 now, for 2.5 volts you have to see how much is the current. It's also 0, so I'm rotating furthermore. I'm just trying to see the current meter ammeter started showing me some value at 2.69 volts. So for 2.5 also we have got 0, but at 2.69 volts there is some current passage in the through the diode, which we can see through the milliammeter, which it is showing as 0.1 milliamperes. At the same time you can even observe this LED starts glowing. See, that means there is some passage of current which is going on through this diode. So still we will vary. Now we have to go for 3. This you have to note down that voltage value where the current meter started showing current. Nothing but we will be knowing what is the threshold voltage of this diode. This voltage where the current started flowing through the diode is from the voltage from where current started flowing through the diode is what we call as threshold voltage or knee voltage or cut-in voltage, whatever be the name which you can give. Okay, but that voltage is what we note down in the tabular column as such. And then the rest of the things will continue the same. So next we will go for 3 volts. So next we will go for 3 volts. Slowly you need to rotate the knob. I want for 3 volts. It's closer, so I'm going slow. Oh yeah, it is 3. So at 3 volts how much it is? It is 0. Okay, it's not coming at 1 point. So let us take, yes, it is 3. Let us take 9 itself, 0.9 milliamperes. Similarly, I'll go with 3.5 again. I will go for 3.5. Now it is 3.5. Yes, it is 3.5. For 3.5 volts, it is 2.7 milliamperes. In this way, again I will go for 4 volts. Then for 4.5, like that. Again we will see how much is the current for 4 volts. Yes, volts. It is 4.7. See, in this way already I have noted down for different colors. Okay, already I have taken, I varied the values for different voltages. For blue color I have taken for 0.25 and like that, 2.5, 2.753, 3.25 like that. I have for 0.25 variation I have taken the corresponding current values. If you take more values, you will be having many points to draw on the graph, then you will get a good graph. So as many points as you can have, that much will be your graph very clear. So I have taken a variation of 0.25 volts. So I have got multiple values, so I can draw my graph in a neat way. So I have taken for blue first. Similarly, next I'll change the diode and put for yellow, and I also repeat the same experiment. A procedure is the same, and note down the corresponding values for green as well, and for also red as well I have note down. So simply what we have to do, once we are finished with blue, now as we have taken already for blue, now what we have to do, once we have taken for blue, just switch it off. Then simply remove these two terminals. This is the diode connection strip. I'll just change it to yellow. Just a negative I have given, same that connections whatever we have given, rest of the connections are same. Just only the difference which I have done is I have moved diode connections from blue to yellow. Once this is also done, I can go for green. This one is green, and also for red as well. So in this way we will be, again I'll turn on the kit, and again I'll start with 0 volts. Then I'll continue doing for the rest of the. So in this way we have to continue for the all different LEDs. This is for yellow, and this is for yellow, and this is for blue, this is for green, and this is for red. So similar procedure we have to follow. So this is what the way, already I have taken the values. So in this way you are going to get the readings. So for different colors, blue, yellow, green and red, I have taken for all the different colors. For these different values, you have to plot a graph. Then you will be getting a graph as I have already shown, model graph, something like this you are going to get. Okay, for this we have to find out what is the VTH also. What is the VTH? It is nothing but it is the threshold voltage, nothing but from where the current started flowing through the diode. That is what we are going to note down. This voltage from where the current started flowing is what we call as threshold voltage for this particular diode. So those VTH values you have to note down and you have to mark that at the end. So this is how you are going to do for this particular